Hello, my name is Mr. Vecchio, and I'd like to welcome you to this presentation on graphing compound inequalities using the three-line method. The first question is, when do we use compound inequalities? Well, two situations they arise. One is when we use equations with absolute value bars. For example, the absolute value of x plus 2 is less than 2. Or we'll also see them when we have inequalities with two constraints. Here we have x less than 2 and x greater than negative 4. It's time for exams. This is a common scenario for students as we get close to exam time, and they know they want to get at least a B, for example, in this case. So what does that mean? Well, that means that the average has to be greater or equal to 80. Okay, that's one constraint. And, of course, the average has to be less than or equal to 100. So if we were to graph this solution on a number line, we would see that it would be any of the grades between 80 and 100 inclusive. Notice that the endpoints are included and we're using brackets. So how do I get the number line? Well, we're going to use the three-line method. The three-line method consists of horizontal and vertical lines. You can see here we have 3 horizontal lines and 2 vertical lines. The vertical lines are for our critical points, and you'll also notice we always put the smaller critical point on the left and the larger critical point on the right. The top horizontal line will be for constraint 1, the middle one will be for constraint 2, and then we're going to use an operator, whether it's an AND statement or an OR statement, and we're going to go ahead and graph the solution on the third line. Let's do a quick little review here. Remember that if the endpoints are not included, this is when we're using greater than or less than, we're going to use parentheses. If the endpoints are included, less than or equal or greater than or equal, you're going to use brackets. If we're dealing with infinity, whether it be negative or positive infinity, there are no endpoints, so we're going to use parentheses. The union operator joins elements in set 1 and set 2, kind of adding all the elements together. This is used with OR statements. And the intersection operator includes the number that are in both sets 1 and set 2. This is going to be used with AND statements. Okay, so back to our problem. We knew that he wanted to get at least a B. We saw that was between 80 and 100. So let's put our critical points on the vertical lines, 80 and 100. And again, 80 is less than 100, so it's on the left. On our first line, let's put the average is greater than or equal to 80. Again, since we're including the point 80, we're going to use a bracket. And since it's greater than, we're going to shade to the right. Our second constraint is that the average has to be less than or equal to 100. Here, we're going to use a bracket at 100 and shade to the left. This was an AND statement, so we're looking for only the points that are in both line 1 and line 2. And we can see this is the overlapping between 80 and 100. Again, the endpoints are included. So our solution is any grade between 80 and 100 will be at least a B. Turns out there are 6 cases. There's 3 for AND statements and 3 for OR statements, and we're going to go ahead and take a look at all those right now. Our first AND statement, similar to what we just saw, this is when they're in opposite directions with an overlap. So x greater than negative 2 and x less than or equal to 4. You'll notice on the right-hand side there, you can also write this as a single compound inequality, where x is between the two numbers. For our critical points are negative 2 and 4, our first constraint is x is greater than negative 2. So this is going to be a parenthesis and shade to the right. Our second constraint is x less than or equal to 4. So this is going to be a bracket and shaded to the left. Again, this is an AND statement, so we're looking for both points in the first line and the second line, and this is going to be from negative 2 to 4. Again, we do not include the negative 2, but we are including the 4. And that's our solution. Our example of an AND statement is when they're going in the same direction with an overlap. So here we have our critical points are still negative 2 and 4, and x greater than negative 2 is going to be parenthesis and shaded to the right. X greater than or equal to 4, we're going to get a bracket and shade to the right. And this is an AND statement. Notice that the second line is a subset of the first line. So in this case, every point on the second line is in the first line. But notice that not every point in the second line is in the first line is in the second line. So we're only going to include the subset, which is the second line. Okay, so again, that's the same direction with an overlap with an AND statement. We take the subset. For our last example with AND statements, again, negative 2 and 4 are our critical points. X less than negative 2 and x greater or equal to 4. Now notice these are going in opposite directions, but there's no overlaps. But using the AND operator, we're only including points that are in both. And here there are none that are in both. Therefore, there is no solution. Take a look at OR statements. Here we have x greater than -2 or x less than or equal to 4. So our critical points are still -2 and 4. X greater than -2 is a parenthesis shaded to the right. X less than or equal to 4 is a bracket shaded to the left. And here this is an OR statement. So since we're adding elements in both sets, you can see that if you were to add those two sets together, you'd actually get the whole number line. So that's from -infinity to infinity, or all real numbers. All right, our next example of ORs, we have, again, -2 and 4 critical points. We have x greater than -2, which is going to be a parenthesis at -2 shaded to the right. For constraint 2, we're going to have x greater than or equal to 4. This is going to be a bracket, and again, shaded to the right. This is an OR statement. So we're going to be looking for things that are in either or, line 1 or line 2. So you notice that in this case, we're going to take the larger set, which is the top line, and that's going to be our solution. And our next one is the opposite direction with no overlap using an OR statement. -2 and 4 still are critical points. X less than or equal to -2 is going to be a bracket shaded to the left. X greater than 4 is going to be a parenthesis shaded to the right. Now, this is an OR statement, so again, we're going to add these two sets together. But you notice there's still that point we're not going to get in the middle. So here our solution is going to be from -2 to the left, including -2, and from 4 to the right, not including 4. And we'll actually write this with the union operator. So these two sets added together. All right, let's go back to our initial scenario. Final exams are coming. I need to get at least a B. Let's take this another step further. Let's say the student had a test 1 grade of 85, a test 2 grade of 69, and a test 3 grade of 90. What must this student get on the final exam, or which grades can the student get on the final exam to get at least that B? Let's assume that the final grade is calculated by the averaging the test grades, but the final exam is counted twice. So let's understand the problem. What is the unknown? Here it's the final exam grade. We're going to let that be X. What are our constraints? Well, we know the final grade must be greater than or equal to 80, so we know the average grade is going to be greater or equal to 80. We also know that the final grade must be less than or equal to 100. And the final exam grade must be between 0 and 100. Let's assume there's no extra credit points. So what's the formula we're going to use? We're going to use an average formula. So here the average grade is going to equal test 1 plus test 2 plus test 3, and then again we're adding that final exam grade twice. And then we're going to divide the whole thing through by 5. So let's set up the problem. Again, the average grade is going to be between 80 and 100. But we know what the average grade is. We have a formula for that. So we'll substitute our formula in. And we know some test grades. So we're going to go ahead and substitute our test grades in, 85, 69, and 90. And of course, X is the unknown value of the final exam grade. And when we simplify that, we're going to get that the 244 plus 2x over 5 has to be between 80 and 100. So the first thing we're going to do is rationalize the denominator. We're going to multiply everything through by 5 to get rid of that denominator. So on the left-hand side, we'll get 400. On the right-hand side, we'll get the 500. And in the middle, the denominator just cancels out. Our next step is to get rid of that. We want to isolate the x term, so we're going to get rid of the 244. So we're going to use the inverse operation of subtraction. We're going to subtract -244 to all sides of the equation. When we're left with that, we get 156 is less than or equal to 2x, which is less than or equal to 256. So we want to have the x have a coefficient of 1. So we're going to have to multiply by the reciprocal, which is the same thing here as dividing by 2. So if we divide everything through by 2, the final exam grade has to be between a 78 and 128. Notice we have our first constraint. When you read the constraints, you always read from the variable out. So here it's x is greater than or equal to 78. And the second constraint, the x is less than or equal to 128. So these are our two constraints with the and statement. However, can x be greater than 100? No, we said that you can get, the highest grade you can get is 100 on the final exam. Therefore, final exam grade has to be between 78 and 100. So again, using the 3-line method, we'll put our 78 and 100 as our critical points. We'll have x greater than or equal to 78, which will be a bracket shaded to the right. We'll have x less than or equal to 100, which will be our bracket shaded to the left. And this is an and statement, so we're going to look for the overlap. It's going to be all the numbers in between, including the endpoints, 78 and 100. So that's what he must get on his final exam grade to get at least a B. And that's how we would see the final solution. Again, the student is happy, he got his grade, and he got at least a B. All right, well, thank you for joining me on this presentation. I want to remind you that you can view this PowerPoint, related videos, and other topics at mrdevecchio.weebly.com. All right, thank you.